In this video, I'm going to cover graphs, specifically graphs of x versus t. So x versus t, meaning that the graphs illustrate how position, which is x, changes with time, which is t. And right now, you see two graphs on your screen. One is flat, and it shows us that an object, whatever that object is located 6 meters away from whatever we consider our point of reference that we refer to as 0. Maybe it's house, maybe it's school, bus stop, whatever you want to think of. So from that point, 6 meters away, and for the sake of the argument, we can say it's 6 meters north, then south would be in the negative direction. So 6 meters north of whatever our point of reference is, our object is right now. And it's still 3 seconds later, it's still there. 6 seconds later, it's still there. 9 seconds later, it's a flat graph, meaning the object does not change its position as the time is ticking. So the object is not moving. The second graph, there are two differences. First, x is marked with kilometers and time is marked with hours. So that tells us that our velocity or speed would be measured in kilometers an hour. But we cannot see the speed right away. We don't know what the value of it is. We only see that it's not 0, and we also see that it's in the positive direction. Let's say positive direction is east, then this is west. So what we see is our object is consistently at a constant rate of motion, is moving in the direction of east. It's not speeding up, it's not slowing down, and it's not at rest. We know all of that because we have a non-flat and one straight line graph, which means that the change in position is consistent. If we wanted to figure out what v is, we could do numeric change in x over change in t. Graphically, it is rise over run. So in our case, I can pick, for example, 1 hour. How did position change? From 0 to 60. So I can also say rise is 60, run is 1. So my object is moving 60 kilometers an hour. If we're talking speed, we can just say 60 kilometers an hour. If we were saying velocity, v with an arrow, we would say 60 kilometers an hour going west. Now let's look at a similar graph right here on the right. I can use that graph to also figure out how long is it going to take to get to 120 kilometers, to travel 120 kilometers. So if I go from 120 to the graph and then go down, I can see that it takes 2 hours. Also, if I wanted to see how far away the object would travel in 3 hours, I can look at 3 hours, go up, 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 see that this lands at 180 kilometers. So 3 hours later, the object will be 180 kilometers. So on the left, we have a red graph, and the slope is negative, which tells me that the object, let's say this is south, then this is north. It tells me that the object is traveling north in the opposite direction of south, and I think that south in this case is positive. So the object is going in the negative direction. It's not at rest, and at 3 seconds, I'm looking at seconds versus meters, in 3 seconds it goes from 6 meters to 0. So my change in x in this case would be negative 6 over 3. So this object is traveling negative 2 meters per second. It doesn't mean that it's slow. It means that it's 2 meters per second. This would be moving in the positive direction. And if I looked at 6 seconds later, it is only at 3 meters away. So 3 over 6 would be 0.5. Now, 0.5 mathematically is bigger than negative 2. However, the speed-wise, it's faster. The negative 2, even though it's negative, is faster than 0.5. And you can see that the slope is much steeper for the red graph versus the green graph. Now look at the blue graph. The blue graph is parallel to the green graph, which means that the object is moving at the same speed, and it's moving in the positive direction just like the green graph. The only difference is it started at 2. So its position already has 2 meters away from whatever our point of reference, which is 0, was. And that, in the nutshell, are the graphs for x versus t, also known as graphs for velocity, because they show us how position changes with time, meaning if we find the gradient or the slope of these graphs, we will find velocity.